So this is Algebra 1, Section 3.4, and this is all about x and y intercepts, and then we're going to go into linear inequalities. Okay, as we talked about last class, right, when we did y equals mx plus b, remember, let me write this down here. Remember when we did y equals mx plus b, we said that that b number is the y-intercept, okay? But sometimes we want to find x and y intercepts when it's not in that form. So here's what I want you to think about. An x-intercept, yes, we know an x-intercept is where the line crosses the x-axis. So crosses x-axis. Okay, it's where it crosses the x-axis. Well, if I have a graph, and let's say I have a line that crosses the x-axis, there it is. It crosses the x-axis right there. So think about that ordered pair. Whatever the x number is, I don't know, 2, 3, 5, whatever. Whatever the x number is, but won't the y coordinate be 0? I mean, if you're on the x-axis, isn't the y coordinate 0? So for x-intercept, yes, it's where the graph crosses the x-axis, but the more important thing to know is it's going to be some x comma 0 ordered pair. So we're going to, anytime we want to find the x-intercept, we're going to let y equal 0. I'll show you what I mean by that when we come down to an example. Similarly, for the y-intercept, yeah, if it's in this form, y equals mx plus b, great, I know the y-intercept. But if it's not, I need to think through the idea. I need to know a y-intercept is where the graph crosses the y-axis. Okay, but think about it. Let's go up here to the one that I've already drawn. Where does that line cross the y-axis? Well, right here at that green point. What's that ordered pair? Well, won't the x-coordinate be 0? And then the y might be, in this case, it might be -2, -3, I don't know. But the y-coordinate, if you're on the y-axis, the x-coordinate, if you're on the y-axis, is going to be 0. So I know the ordered pair is 0, comma, whatever the y value is. So if I want to find the y-intercept, if it's not in y equals mx plus b form, all I'm going to do is let the x equal 0. Okay, so when I come down here and I look at number 1, it says find the x and y intercept of each of the following. So you don't have to change this into y equals mx plus b. I just need to think to myself, okay, x-intercept, I know the ordered pair is going to be some x number, we'll figure that out in a minute, comma, 0. So I'm going to let y equal 0. So if I put a 0 in for y, I'm going to have x minus 2 times 0 equals 4. Well, isn't 2 times 0 just 0? So really that's not even there. So all I have left is just x equals 4. That means the x-intercept is 4. Okay, let's try the y-intercept. Well, I know to find the y-intercept, I know the ordered pair is going to be 0, comma, whatever my y value is. So what does it say for y-intercept? It says let x equal 0. So if this time, I'm going to put in a 0 for x. If I put in a 0 for x, I'm going to have 0 minus 2y equals 4. Well, forget the 0. I mean, it's like it's not even there. If you solve and you divide by -2, if you divide by -2, then what does x equal? Well, the -2's cancel, and what does y equal? Don't you end up with 4 over -2, which becomes -2. And so this is what we were looking for. Okay, let's try it again. For the x-intercept, I know it's going to be something, comma 0. So I'll put a 0 in for y. So I'm going to have 3x plus, if I put the 0 in for y, isn't that whole thing going to be 0? So plus 0 equals -15. So I don't even really need that plus 0, right? And so if I want to solve for x, wouldn't I just divide by 3? So if I divide by 3, doesn't that mean x is going to be -5? Let me put that in red so you can tell that's my answer for the x-intercept. And then for the y-intercept, I'm going to let 0 equal x, and then I don't know what the y value is. That's what I'm trying to find out. So if I put a 0 in for x, I'm going to have 3 times 0 plus 5y equals negative 15. And so this time, if you want to solve, that 0 is not even there, divide by 5, and won't you have negative 3? I don't know why I wrote them up there instead of down here. I guess I could have. So we said the x-intercept was negative 5, 0, and the y-intercept was 0, negative 3. And then let's see, we had 4, 0, and 0, negative 2. Okay. When I look at it on the graph, I can just look at the axis, right? If I want the x-intercept, well, where does that line cross the x-axis? Well, isn't that at the point 3, 0? And then where does that line cross the y-axis? Well, isn't that at 0, 6? On this one, so if I want the x-intercept, it crosses right here in the middle. So I'm going to say that's 1/2, comma 0. And the y-intercept, I think it crosses right down here, doesn't it? So that's going to be at what? 0, comma negative 3. So of course, if you're looking at the graph, all you have to do is look at it to know the x and y intercept. You don't have to do the plugging in 0 like we did, on the first part. Okay, so one other thing we're going to talk about is graphing linear inequalities. And so if you look down here at example 3, this is an example of a linear inequality. Notice the difference is that instead of having an equal sign, I have this less than sign. Okay, so how do I graph those? Well, step 1, you just graph the line, meaning think about it as mx plus b, right? Just pretend like it's an equal sign. So for number 3, forget that it's a less than. The b is negative 4, so my y-intercept is negative 4. My slope is 3, so up 3 over 1 as many times as you want to do that. Okay, and so if I were to draw that line, it would be this. Remember how I told you before on these, make sure you draw it the full length of the graph. So there's my line. Okay, and then number 2, you need to decide if your line should be dashed or solid. Okay, decide if your line should be dashed or solid. And the way you tell it is you look at the inequality. Do you see that this inequality is just a less than? It doesn't have an equal to there. Okay, so the equal to means it's solid, but if it doesn't have the equal to, if it's just to the less than or just a greater than, that means it's a dashed line. So I need to make this line look like a dashed line. So I'll just kind of put some little eraser pieces in there, right? So I've got this dashed line. And then the final thing you have to do is you have to decide if you should shade above or below the line. Okay, and the way you decide is, again, you look at the inequality. It's a less than. Less than means lower, so you're going to shade below the line. Well, when I look at this line, the part of the graph that's below the line would be all of this. So I shade this part. Okay, so look at number 4. Start over. So ignore the greater than or equal. Just pretend like this is mx plus b. Now be careful, don't let them get you. Notice the b is right here, and this is the m, right? Because the m is always right in front of the x. So in this case, the y-intercept is 5. So there's my y-intercept. And then I'm going to mark off a slope of negative 3. So down 3 over 1, down 3 over 1, down 3 over 1. So I draw my line. Again, draw it the full length of the graph. So there's my line. Okay, the second thing I do is I decide, should it be dashed or solid? Well, notice it has the little equal to right here. So it's a solid line. And then finally, do I shade above or below? Well, when I look at the inequality, notice the inequality is a greater than. Greater than means above. So I'm going to shade above this line. Well, do you see that the values for y that are above this line are going to be over here. So it's not about left or right, it's about above or below the line. Okay, if you look at number 4, all right, I can't graph this line because it's not in mx plus b form. So the first thing I have to do is just like we did in the last, when we were doing the grading before, is I'm going to have to solve for y. So I'm going to subtract the 2x. So I've got negative 6y, keep the greater than, negative 2x, and then that's a plus 12. Okay? So in order to solve for y, I'm going to need to divide by negative 6. So divide everything all the way across by negative 6. So on the left, I just have y. Now, remember what happens when you're solving inequalities. Anytime you divide by a negative, you have to flip the inequality. So instead of a greater than, now I'm going to flip it. It's going to become a less than. And then finish simplifying. Negative 2 over negative 6 is 1/3 x. And then 12 over negative 6 is negative 2. Okay, so that's the line I'm going to graph. So put on your y-intercept of negative 2. Put on your slope of 1/3, right? Slope of 1/3. So I draw my line. I've got my line drawn. All right, we have to decide, is it dashed or is it solid? Well, notice it's just a less than. There's no equal to. So it's a dashed line. So I've got my dashed line. And now I have to decide on shading. Well, it's a less than, and since it's a less than, here's what I'm looking at right here. Since it's a less than, I'm going to shade below. So I'm going to shade all of this down here. Okay? When I look at number 5, y is less than or equal to 3. Well, notice on this one, I don't see an mx plus b. In fact, there's no x's. Well, remember what we said last class? If there's no x's, if it's just y, isn't it a horizontal line? So if I were to draw a horizontal line at 3 for y, there's a horizontal line at 3. Okay, and there's my line. Decide dashed or solid. In this case, because of the equal to, it's a solid line. And then remember, less than means below, so I'm going to shade everything below this line. So I'm shading all of this. Okay? And then finally it says determine whether the given order pair is a solution to number 4. Okay, so we're looking at number 4 right here. Well, a solution means does it fall in the shaded region? So 0, -3, 0, -3 would fall right here. That's in the shaded region. So that means yes, it is a solution. I'll say here, yes. I'll just say yes, it is a solution. We're still looking at number 4, letter B. What about the point 22? Well, the point 22 is up here. All right, that is not in the shaded region. So that means no, it is not a solution. And then the point -3,8, -3,8, even though it's off the graph, I can tell it's way up high, right? -3,8, which means it's not in the shaded region. So it's a no. Okay, on number 7, it says determine whether the given ordered pair is a solution. Well, I don't have to graph this equation in order to know if it's a solution. I mean, if I already had it graphed, great, it's easy to tell. What I could do is I could just plug these numbers in for x and y and see if I get a true statement. If I'm going to plug in a 1 for x and a -1 for y into that equation. So I'm going to have 3 times 1. And then it says -4y, so -4, in place of y I'm going to put -1, and then the equation says greater than or equal to 12. So let's see if this is true. Is 3, and then -4 times -1 is going to become a +4. Is 3 plus 4 greater than or equal to 12? Well, no, 3 plus 4 is 7. That is not true, so this is a no. Okay, for the next one, I could do the same thing. I could put in a 0 for x and a -3 for y. So I'm going to say 3 times 0. Notice I'm just plugging it into that equation. Minus 4 times -3 in for y. Greater than or equal to 12. Well, let's do the math. 3 times 0 is 0. -4 times -3 is +12. is positive 12 greater than or equal to positive 12? Well, yeah, 12 equals 12, so that's a yes. And I know there's another one there, but I don't think we need that. I think you got the idea. All right, so that is section 3.4.